everybody, our viewers, and we are here to present a short introduction to complex numbers. Thank you, Steve Babu Subiri sir of Math Department for giving us this opportunity. First, we like to start from Subodh Bhattrai. He's gonna do some basic introduction to complex numbers.
Good evening, everyone. So today I am going to do some introduction on complex number. So some of the objectives of my part is to do the introduction and the definition and some algebraic addition, subtraction, multiplication, inverse of those complex number and conjugate as well as the absolute value of complex number. So here I begin. So basically, how did the concept of complex number came? So let us take the example quadratic equation. As we can see, like we get x square equals to minus 4. This has no solution. Like the solution cannot be expressed in terms of real number. So complex number was introduced basically to find the solutions for cubic equation, especially to solve this equation, this I whose value is minus 1 was introduced to get the solution of this kind of equations, and this will be explained further by my friend almost later on. So let me do like a graphical analysis of complex number. So if you take this, then this x will be the real part, whereas this y will be the imaginary part. And then the complex number, it is basically an order pair of this, and it is denoted by, let's take z. In this one, x is the real part, whereas y is the imaginary part. But this x and y, they are both real numbers. X and y, they are both real numbers. So the basic concept of complex number is this. Now let me go to the algebraic expression like addition, subtraction, multiplication of this complex number. So the first one is, let's take two complex numbers, a comma b and another c comma d. If a comma b is equal to, for this condition to be true, it is only true if and only if a is equal to c and b is equal to d. Yeah, this is the basic property. And the next one is addition, z1 c comma d. z1 plus z2 equals to a plus b comma b plus c. Then comes the multiplication. If we take two numbers same, a comma b, then c comma d, then z1 into z2 will be ac minus bd comma bc plus a. This is the multiplication, and it is one of the most important, not most, but it is important. We can also use using the flame rule. It will be easier for us to multiply using the flame rule. And then let me go to the next one, that is multiplicative inverse. That is, if Z1 into Z1 inverse, if you multiply Z1 with its inverse, then the product will be 1. This is the one, and now let me go to the conjugate of complex number. Conjugate. Complex. Now, if Z1 is a complex number, then its conjugate will be denoted by conjugate of the Z1 number, and it is defined like, if Z1 is equals to A plus IB, then its conjugate is, which is A minus IB. Let me do one graphical representation of conjugate number. Let's take a point P, A comma B. This is y axis, this is x axis. Then it becomes like A comma minus B. So basically, conjugate is a reflection of a point here P, A comma B under x axis. So conjugate can be basically explained by the reflection of any point under x axis. So the conjugate of A plus IB is given by conjugate of A minus IB. Now let me explain you about the absolute value of complex number. Absolute value here A comma B. If Z is equals to A comma B is a complex number, then its absolute value is taken by the modulus, which gives us A square plus B square. So as I have done so many graphical representation here, I would like to do one for this one, because it will be much easier to understand. As we already know, this y is the imaginary part and x is the real part, A, and then this be IB. Then modulus of Z, this will be equal to under root of A square plus B square, as Z is equal to A comma B. So I have explained my basic terminologies related to complex number, conjugate of complex number, and its absolute value. So for further explanation, I would like to call Rajma Gautam.
Good evening, everyone. Once again, I'm here to prove one of the properties of absolute value of complex numbers, which is known as triangle inequality. It is one of the most asked questions in our NEV course. So before that, we need some properties of complex numbers, which are these are the properties that we're going to use to prove triangle inequality. Okay, so first triangle inequality is we need to prove this. to this. So first I'm gonna take z1 plus z2 as in whole, and we can use this property to 1 plus z2 multiplied by z1 plus 2 bar. We are using this property for opening this. Now thus now I'm gonna multiply these two. Now again we can use this property to make it modulus square. So it will be z1 square plus z2 z1 into z2 plus z2 into z1 plus modulus z2 square. Then we're gonna put this over the respective place. So the z plus as you can see, the bar is not in the same position, so we can't apply this right now. So we need to change it so it will be in the same as the property there. So what we're gonna do is we're gonna add one more bar, so it will follow that property. Now we can write two RE bar. From this step, now 2RE Z1 Z2 bar, we can use this property. So it will using this property, the I'll show you. Now the equals to changes into smaller than or equals to. So we can write so using this property, this equation will be this, but we need to change the sign into lesser than or equals to then this, which means this this is lesser than or equals to this. But this is greater than or equals to this. So we need to remove this bar, so we're gonna, as it is modulus, we can just remove it easily by using this property. And now we're at the final stages. Now we can see we have square here. So whole square. Hence this is as we can write this as this is the triangle inequality of two complex numbers z1 and z2. Now I like to explain, not explain but do questions about root, square root of complex numbers. I'm gonna do this quickly as time is running out. There's a simple question, 5 minus 2li. To find out the square root, we need to first let two numbers x and y be the square root of complex number 2li, and we can write this complex number as plus ib. So as a is 5, b is minus 12. Now the formula for first root is a plus root a square plus b square by 2, 1 by plus minus. This you can just put the values in. 5 plus 5 square plus minus 1 by 2, which is equals to plus minus 3, and for y the formula is plus minus a plus b square minus a square root by 2 square plus a. No, it is not squared, sorry, which is equals to plus minus 2. Now, as you can see, b is negative, so what we should do is when b is negative, we need to give them opposite signs. So, when x is equals to 3, then y is minus 2, and when x is minus 3, then y is plus 2. So the roots are 3 minus 2i and minus 3 plus 2i, which we can write plus minus 3 minus 2i. Thank you. Now I like to call Anmol for proving the set that Subodh said.
Good evening everyone. Today I am here to give you a basic tip in order to solve problems related to complex numbers. We know I, which is also known as iota, is equals to root under minus 1, which can also be written as 0, 1, whereas 0 is the real part and 1 is the imaginary part. We can see many students make a simple minor mistakes in exam. So let's take an example. We can see many students take root common here, like 6 and write 40, which is completely wrong. To solve this correctly, we need to write like root under minus 25 into 6. We know I square is equals to minus 1. And by removing this root, we can write 5i into 6i and 30i square. Like I said, I square is equals to -1. It is -30. So thank you. Hope you do your exam correctly next time. Thank you very much.